Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lufi bin Muhammad Shakib. So today I will present about the assignment 2, recyclable material classification by using convolutional neural network. For introduction, recycling is the process of collecting and processing material that will otherwise be thrown away as trash and turning them into new product. Recycle can benefit your community and the environment. And lastly, the recyclable material include many kinds of glass, paper, cardboard material, plastic, tires, textile, batteries, and electronic. So the recyclable material classification is the task is provide the image of PET bottle and can aluminium. So there are two types of the image that we will to design our own CNN model to train the data without overfitting or underfitting. So there are two classes that comes to the output in the task given. For convolutional neural network consists three layer. There are two consecutive layers of convolution polling and one fully connected layer of classification. The CNN process got five types. The first is a convolution layer. Second is the stride. The third process is the padding. Next is pooling layer, and lastly process is a fully connected layer. So this is the VGG16 model. VGG16 model is a model that achieve 92.7% top 5 test accuracy in ImageNet, which is the dataset of over 40 million images from 1000 groups. The VGG16 architecture is a fixed size image of 224 times 224 RGB in the input to the COF1 layer.
Assalamualaikum, my name is Muhammad Faris bin Muhammad. So now I'm going to present a demonstration for our project for the task 1 and task 2. So for this project we need to use a CNN, which is a convolutional neural network for our recycled material. So we were provided images by our lecturer of a PET bottle and aluminium can. So by using that, we need to create our command to run CNN, which is we need to train all the images that were provided. So the first thing is we need to import the Google Drive of a can and pad, train and validation. So we run the connect to the Google Drive, which is where we save our image. So the drive already mounted, and then we feed a dataset directory, which is I save in the folder project vision, and then we run the dataset. After that, we need to create our create train and validation data directory. For example, the train we use the directory for the train vision, and the can pad for the train, and can and pad with a different directory we used to run it. So here the line of can train 156, pad train 310, can validation length is 77, pad validation length is 133. So we use a TensorFlow to run this program. Okay, done. After that, we need to construct our own CNN model, which is we use a convolution 2D and also max pooling convolution 2D 32, 64, 138, and the max pooling 2 times 2 only, and the dense we use 512, and then we create a CNN model. Here the output from the CNN model, and then we use for this step we need to skip because the task one is it doesn't want to use a VGG, so we can skip the step, and we try to pre-process the input data for our CAN and PET. So all the images now is pre-processed the input. So by that we found the 466 images belonging to two classes, which is a CAN and PET, and 210 images belonging to classes. It will detect two different classes, data bash and a label shape is 10. So we start a training process. We use a step per epoch is 20. So for this task one we use 30 epoch only, and the validation step is 20. So we try to run, and we need to wait until 1/30 to finish the epoch. If you can see the accuracy here, we can see that the accuracy is quite accurate. If the value is near to 1, it's good, because the if accuracy is high, the validation loss or validation accuracy is might below than 1. So here we need to wait for until 30. So right now it's 19/30. So the process is need some time to done. We also can change our epoch into 20. It will might be effect to our accuracy if we change is more high or low. So here done our epoch from 1 until 30. So from the epoch we plot the outcome for the accuracy, validation accuracy, loss, and validation loss. So we will come out a figure for our training, validation accuracy, and the training and validation loss. So based on the figure that we see, sorry. So training and validation accuracy for the dot is will be a training accuracy. It's quite the first three, the accuracy might be less or not too accurate actually, because the value is not to 1. For we can see this first is 0.63 I think. So until the more time epoch we process, the more accurate the training accuracy, but it's not too stable. For validation accuracy, the value not too stable. Based on the training and validation loss, the training loss is good actually, because it's not near to the 1. If our training accuracy is high, then our training loss must be low actually. Must be low within the value. For the example is 1, so it's below than 1. So this is my actually the high accuracy, just 1, just 2 or 3 training loss is get a high value. Our validation loss for our data set is is better than training and validation accuracy. So we can assume that the training and validation accuracy is not stable, but more often is accurate, and the training and validation loss is good. For training loss and validation loss is quite stable. So we move to part 2, which is we need to use a VGG to train our data or outcome or input. So we start the same process as before this. So we import our Google Drive to train and also find the dataset directory. Okay, done. So here to create a train evaluation, it will detect the same value because the dataset is already in each folder for train evaluation. So we use a TensorFlow. So we construct the CNN model. So for the task 2, we need to construct P3 model with VGG. So we run this VGG model. So we use a convolution 2D max pooling also. The total param is 14. So training param is 0, non-training. So we use pre-process the input data. It's always belonging to two classes for cat and pet. Aluminum can. For the start training process, we use same epoch day for 30 epoch, and step per epoch is 20, and relation step is 20. So we need to wait until we proceed to the graph outcome. Actually, we can see this the accuracy is might be low because it's 0.6 only. Relation accuracy also 0.6. It's getting better and better. The epoch 17 and above can get a one value accuracy. Is quite good. So here done our running for epoch 30. So we move to the plot the outcome from our result, and we can see the training and validation accuracy and also the training and validation loss. As you can see here, the training and validation accuracy, for training accuracy, the dot one is quite better because the value is more getting to 1, and the validation accuracy is not too stable actually. Based on the training and validation loss, the training loss is, I think it's more better than previous without VGG. But we can see the previous one for validation loss is more stable because only one waveform quite, and the validation loss for this using a VGG is not also stable, same as a training and validation accuracy. So that's it, demonstration for task 1 and task 2. Thank you.
Last part is the conclusion. Based on this assignment, we can conclude that we managed to fulfill the task 1 and the task 2, which uses CNN models to train an image and analyze its performance. So by using the Google Colabs, it can turn the trained dataset to a better CNN model. so the accuracy will be more accurate while using the VGG16 without pre-trained model. That's all for our group. Thank you.